Hi mathematicians, today we're going to be reviewing learning target number 2, which is I can convert between mixed numbers and improper fractions. Before we talk about converting, let's first do a quick review on what a mixed number is and what an improper fraction is. First, let's talk about mixed numbers. The key word here is mixed. A mixed number is called a mixed number because it's a combination or a mix of two different things. First, we have a whole number, and then we also have a fraction of a whole. So an example of a mixed number could be something like this: 2 wholes and 1/3. And we would draw a picture of that mixed number by starting by drawing our 2 wholes. So here's 1 whole, maybe that's a pizza. Here is a second whole, and I'm going to color in the whole thing twice. So there are my 2 wholes, and then I also have 1/3. So I can divide this circle into 3 pieces and then color in one of them. So there's 2 wholes and 1/3. Here's 1 whole, here's my second whole, and here's my 1/3. Secondly, we have improper fractions. When you see that word improper, you probably right away think of like wrong or not following the rules. And that's kind of right. An improper fraction does not really follow the rules. It doesn't follow the rules because in this situation, the numerator is greater than the denominator. And that's not usually how you would write a fraction. Here's some examples of improper fractions. So first of all, maybe we have something like 7/5. You can see that my numerator, my number that's on top, is the greater one. Another example of an improper fraction could be something like 5/3. Again, you can see that the numerator, that number on top, is greater. Let's also draw a picture of what these fractions, these improper fractions, would look like. So let's first go over to 7/5. So I'm going to start, and this time I'm going to use bars for my fractions. I need to draw 7/5. So I'll start with 1 bar and divide it into fifths. 1, 2, 3, 4, 5. And I need to color in 7 of them. So let's see how many I can do so far. 1, 2, 3, 4, 5. So far I only have 5/5, but I need 7/5, so I need to draw another bar. Here's my second bar, also divided into fifths. I already colored in 5 of the fifths, so 5, 6, 7. That's a picture of what 7/5 looks like. Let's go over to 5/3 and do the same thing. So I need to draw thirds because that's what my bar is separated into. That's what my denominator tells me. So I can start with 1 bar divided into thirds. And now I need to color in 5 of my thirds. So far I have 1, 2, 3. So I must draw a second bar so that I can get to 5/3. I've already colored in 3, so now I have 4, 5. And there's an example of what 5/3 looks like. When you're doing an addition or subtraction problem, sometimes when you're done, your answer will be an improper fraction. Improper fractions are not written correctly, so we need to change our answer to a mixed number. So let's say you're doing your math, you've added, and you're done with your problem, and your answer is 9/5. I know this is an improper fraction because my numerator, my number on top, is greater than the denominator. There are two strategies that you can use to change an improper fraction into a mixed number. First of all, we can just draw a picture, like we did before. So in order to draw a picture of 9/5, I need to draw 9/5. So let's start with a fraction bar divided into 5 pieces. And I need to color in 9 of these pieces. 1, 2, 3, 4, 5. That's only 5, and I need to get to 9, so I must draw another bar. Okay, let's keep going from 5, 6, 7, 8, and 9. So now I can write my answer as a mixed number. I can see that I have one whole bar colored in, so that would signify one whole. And then my second bar has 1, 2, 3, 4 out of 5 shaded in. 4/5. So as a mixed number, this would look like 1 and 4/5. You can also use numbers to convert. Here's my 9/5 again. I need to ask myself inside my head, how many times does 5 fit into 9? If I count by 5s, 5, 10, 5 only fits into 9 one time. One whole 5 fits into 9. How many more would I need to get to 9/5? So far, I've used 5/5. 5, 6, 7, 8, 9. 4/5 would be left. My one whole, you can think of the one whole as signifying 5/5. 5/5 plus 4/5 would give me what I started with, which is my 9/5. So you can decide what works better for your brain. Last but not least, there are going to be situations where you have a mixed number, but in order to help you add or subtract, you need to change it to an improper fraction. So here are two strategies to do that. Again, we have a picture strategy and a number strategy. So let's say our mixed number is 3 wholes and 4/5. One way that we can figure out how to write this as an improper fraction is to just draw out our picture. So I have 3 wholes. So I need to draw 3 whole bars. Each of these bars is separated into fifths because that's the fraction that I'm working with. So let's go ahead and divide them each into fifths. And since I had 3 wholes, I'm going to color in all of them because it was the whole 3 times. I've drawn my 3 wholes. Now I need to draw out my 4/5 as well. So I'm going to do one more bar divided into fifths. And now I need to color in 4/5. So 1, 2, 3, 4. Now I can look at my picture and I need to count to see how many fifths I have all together. So I have 5, 10, 15, 16, 17, 18, 19. So 3 wholes and 4/5 as a mixed number is the same as 19/5 as an improper fraction. Now that took a while. It was a lot of drawing. So you can also use numbers inside your head. Let's do a different one. Let's say that you have instead 4 wholes and 2/3. We're going to do this 2 different ways. One way you can do this is by adding the wholes together. I have 4 wholes. that means that I have 3/3, because that's 1 whole, 4 times. So that's 2 wholes, 3 wholes, 4 wholes, plus the 2/3. So there are my 4 wholes, plus the 2/3 more. So to add that together, 3, 6, 9, 12, 13, 14. So my answer would be 14/3. A shortcut strategy that you can use also is that you remember that you're going to multiply the denominator by the whole and then add the numerator. So you would do 3 times 4 plus the numerator, and it's still going to be over the same denominator. 3 times 4 is 12, plus the 2 more, and I get 14/3 again. And that's it.